Good morning, everyone. My name is Yudhara Wedaswara. Today, I would like to present our research with title Text Classification using Genetic Programming with Implementation of MapReduce and Scraping, which is a collaboration between University of Mataram, Seoul National University, and Telkom University. First part is introduction. Background of our research is a classification of text documents on online media is big data problem and requires automation. Categorizing term of large data requires parallel processing. Hadoop MapReduce is parallel processing framework for big data that has been widely used as an OLAP or online analytic processing platform. And our research is the study aims to perform text classification with association rule mining based data pattern analysis. Through association rule mining, it's hoped that data pattern between labels can be known, affecting the acquisitions of accuracy. The research also aimed to form a data collection system through web scraping, pre-processing using Hadoop MapReduce, and text classification using genetic programming. The second part is review of presented system. General view of system shown as on right side, which data is collected through web scraping process using a Scrapy library in Python programming language. The MapReduce process allow parallel processing, making it suitable for processing large amount of data. Genetic programming is used to extract text patterns, calculate similarity and dissimilarity, and through interpretation to main research objective, which is a text classification. So the flow is shows below. Okay, so next part is flowchart of the system, also shown on the right side. The pre-processing process, pre-processing consists of input URL, which is come from Science Direct, and text download by Scrapy. Text data is processed by MapReduce until it become an object ready to process by genetic programming. Genetic programming perform words level based on frequency of occurrence. Genetic programming will perform the rule extraction by prioritizing words with high to low frequency occurrences. This is a diagram of MapReduce that we use. The mapping process is carried based on data per class by separating the term word from the download article. The reduction process is also carried out based on each class by tokenizing for terms that have been in previous map. The final process is done by separating words that appear in their respective class as unique and similar terms. So we separate them into unique and similar term. Third part is genetic programming rule extractions tree structure. Yeah. So this is again structure of tree, again single tree, which only one tree there. So we separate into label, most frequent, second frequent term, which in programming represents as object with a multidimensional array and with its connections, and term is represented in the graph with level and node type and index. Okay. This is the extra rule of single rule. The first column of rule structure allow indicate the separator between precedent and dependent. So this label usually with this term, and it's come from shortest to longest. The precedent is placed by a label, and the dependent indicates the frequent item set. The length shows the number of nodes dependent. Confidence and support show evaluation result, association rule mining, which can be seen in previous studies that we are using before. Okay, so the score, the score is shown like this with combination of which is length, confidence, and support. Okay, next is a multi-tree gain structure, which also um, uh, similar tree process, but it's separated into different tree, which each label is not connected between the tree, not like the single tree, and it has more complicated connection status, which is have a multi-array in there, but still can represent using a compact data structure. Okay. So this is extractor rule of multi-tree. So it shows multi-tree. The example shows some of the rule extracts by L1 and L2, not L3 because not enough space. L1 label 1 shows a maximum of 2 dependent combination because there's only 2 level. Okay. At the same time, L2 can reach the 3 combination because it's a 3 level. So L2 only, L1 only 2 level, and it's 3 level. Okay, so we move to evaluation result. So this is a web scraping result of data. Data is collected from the latest article as December 1st December 2021 up to a limit of 6,000 titles for each keyword: IoT, big data, and machine learning. The horizontal header shows its keywords that has been scrapped, and the total. Each keyword collects as many as 6,000 titles, and abstract of total 18,000 articles. So this is collected. It is used. So there's some article that duplicate between some between labels. So that's like also containing big data and also containing machine learning. So we can see there which is article that have a bot keyword in their publication. Okay, so next is methodology research. In mapping process, each words in the article separates the number of the words shown by the table, a specific word that have gone through the previous stop or removal process. In the mapping process, there's words where extracts from all keyword. The tokenizer process is carried out so reduction by counting the same words to get the term frequency. So this is a uh, reduce results, and only unique word is used as rule extraction in the genetic programming. So we can see the similar words that occurs in each library there. Okay, so comparison of single tree and multi-tree as evaluation includes the number of generated rule, the average length of results, rule and average support generates. The best support result are obtained in the multi-tree data with this and the length of 5. So the number of rules generates multi-tree is greater than initial test, the data which decrease from the single tree with 127 rules. You can see there. So next is a description of common and specific rule, which is a similar concept to the TF-IDF, but it's used in genetic programming for text classification. The common rule is a rule that applies to all keywords, and a specific rule, a rule that only applies to one keyword, okay, or one label. So we can see there, there's more common rule in there. Okay, so next is it was the single tree and this was the multi-tree. So single overall trees produce more common rule than the multi-tree, surprisingly, but not large differentiation. Okay. Sing However, for specific rule, the multi-trees produce better result because they are independent. Then single tree, the two models do not significantly differ for number rule generate support. So last evaluations is compare with other algorithm that have a similar concept, which is a decision tree. For the list data, which is 3,544, the decision tree has highest accuracy 0.679. A single tree has higher accuracy than decision tree since data is increased. The multi-tree produce better accuracy than the decision tree with total data, larger data. On average, genetic programming with single produce the highest accuracy, followed by decision tree, and smallest by multi-tree. So single tree still better than decision tree with not quite differential, but multi-tree is lower. So single tree can be best on there. So conclusions. So we have using MapReduce to tokenize and store words removal, and we also do the evaluations of classification with single tree reach the best result. The evaluation also show that RM are not the line, the classification result with have a high support there. For future work, we will test the different data topics and hardware performance analysis will be carried out in data processing. Okay, thank you very much.